So again, you wrote today's date and you wrote today's objective, which is I can determine patterns that identify an exponential function from its related common ratios, right? And I'm asking you to find the 200th term of an equation. So what's one way to do this? I know some of y'all got it. How'd you get it? Replace x with 200. Now, by the way, 200th terms are the x values, not the y values. Okay? Earlier, someone told me, Mr. G, the answer is 69 because they saw 200 on the y value of a table. But 200 is actually the x value, right? In the back. So, oh.
Is that you?
That's my phone. Uh-oh. Okay, one second. Gotta turn this off. Nope. I'm still... Alright, so, again, we replace x with 200. So, 3 times 200 minus 7. What's 3 times 200? 600, and then minus 7. That's 593, okay? That's one way to do it, okay? So when you have a really high term number, it's sometimes easier to just plug it in algebraically, okay? You could have done what? Graph it, and how do you get the table? Control T. So you can graph and hit Control T to get the table, and then from there, you could scroll all the way down to 200 on the left-hand side. That's a lot of scrolling, so sometimes algebra is faster, okay? Let me pass out the notes. I'm passing out a piece of paper so you can do the little thing we're doing at the bottom there. One for everyone over there, too. Okay. So, let's take a look at the 1.4 notes. Last notes we did were linear. This time we're talking about exponential. Goodness gracious. Okay, so writing exponential functions. Here's an example. If Miranda shared a cookie recipe on social media with 3 friends, and each of those friends shared the cookie recipe with 3 of their friends, multiplying by 3 each time, right? If that trend continues, how many people will receive a cookie recipe in the 5th round? Okay, so basically 3 times 3 to the 3rd power, 3 to the 5th power. Okay, so 3 times itself 5 times. Okay, that's an example of exponential as long as you're multiplying each time, right? Okay, down here, everyone has a scratch sheet of paper? Don't fold your warm-up. Don't fold your notes. Okay, this says begin with a sheet of paper. Now, first of all, 0 folds is how many layers? Just 1 layer, right? So, 0, 1, makes sense. Now, fold it in half. How many layers do you have? You just count vertically, 1, 2, boom. Write that down, and then keep folding it and keep writing down the number of layers. And let's see if you can get more than 7 folds. Can you do it? Let's see, all right? Let's get started. All right, so everyone folded. Anybody get more than 7 folds? Who? Well, you said you would. You gotta have more. You gotta be like Mr. G, you know? Don't fail. 3, look, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, don't say that. All right, I'm just kidding. I counted wrong. So, let's see here. All right, so I got 1, 2, 3, 4, 5, 6, 7 folds. Anyone get more than 7? Now, I think it's supposedly impossible to get more than 7. More than 8? Oh, okay. So, I don't know, 7's pretty tough. 8, easy. I'm kidding. All right, well, anyways, fill this out. What about 2 folds? How many did you get? How many layers? 4. By golly, there's a pattern here. Now, what about the 3rd fold? How many? 8. Every time when you fold it over, it's just doubling each time, right? So 16, 32, 64, okay? Is everyone good on that? It makes sense when you fold, you double. You fold, you double. The layers, right? Okay, so you can go to the next, flip the page over. Not over, but flip to the next page. Now, I put this at the top from the front, okay? And now it's asking us, what's the difference between the number of folds in consecutive rows in the table, okay? So the difference in the number of folds each time is 1, right? Right, and no one's on our phone. So, number 2, now we're going to rewrite all this, oh no, we're going to rewrite all this stuff over here. 2, 4, 8, 16, 32, 64. Okay, we just redrew the, filled out the table of folds and layers. Now it wants us to find the difference between the number of layers, which is on the right side. And y'all know difference means subtraction. So 2 minus 1 is 4 minus 2. 2. And then 8 minus 4. 16 minus 8. Okay. So all of those are called differences. Now here's my question to you. Is there a common difference? Okay. The differences are all different. Okay. So then, oh my gosh. Can you just move? Thank you. There we go. Boom. All right. Are the finite differences over here, are these constant? Are they the same? Are they constant? Right? Right? Are they constant? What do you think? Is this constant? Constant means the same number. So no. Okay? How can you tell? The differences differ. The differences are different, right? So what pattern do you observe in the differences? What's happening each time? Doubling, okay? So, is this linear? Times 2, remember linear is not multiplying, it's adding. So is it linear? No. So what is the ratio? Now here's the deal. If it's not changing by a difference, by adding or subtracting, then it has what's called a ratio. Okay, so ratio is when you multiply or divide by a number, okay? So since we are multiplying by 2 each time, what is the ratio? 2, okay? Now, could we figure out the 7th layer? If we got 6 is 64, what would the 7th layer be? 128, right? You can just times it by 2 again, right? So the 7th is 128 layers. The 10th fold, we're gonna wait on that. Oh my gosh. Here we go. We're going to wait for the 10th until we get an equation down here on number 9. But number 8, what type of function is this when it's multiplying? What do you call it? Okay, remember, if it's not linear and it's multiplying, that's exponential. So, we want to take that graph we had, and we need to get an equation. How do we do it? Lists and spreadsheets, menu 4-1. Not 3, but menu 4-1A for exponential. Question? So, you could keep doubling. You could. But I'm saying, let's say they pick 100, okay, or whatever, you know. So I'm just modeling, you know, how to go from an equation to the table and look at the table. So, yeah, you could keep the table going. So real quick, we're going back to this right here. I'm going to leave it on the side so I can get to this. So I'm going to press on. I'm going to go to my spreadsheet, okay? X and Y at the top, right? Now, I'm going to use 0, 1, 2 for my for my number of folds, and then my number of layers, 1, 2, 4. Okay? Now, again, for exponential, we hit menu, 4, 1, A. X for X, Y for Y, and our equation. Now, remember this from our quiz. You have to write this correctly. A times B to the power of X. So 1 times 2 to the power of X, like it says right there. Let's write that down. So Y equals 1 times 2 to the power of X. I like to put the second number in parentheses. You don't have to, but so 1 times 2 to the power of X. Now, do we know how to get a table from that? First, we got to type it into graph, and then yes, we hit Control T. Here we go. Let's go to hit graph number 2. 1 times 2 to the power of X. Okay, so you see what it looks like? Kind of looks like a half pipe. Gonna be skating, bro. Like a thrasher or something. Like your bands are off the wall or something. Gonna do a sick kickflip and an ollie, bro. Hanging in airtime, right? Okay, well anyways. So 1 times 2 to the power of X. Let's hit Control T to get that table. And I want to figure out the 10th term, so I can scroll down. At 10, I have 1,024. So over here, 10th fold, 1,024. So I can use this equation using Control T after I graph it. Cool? All right, next page, flip it. Flip, flip, flip. Flip, flip, flip. What is the area of the sheet of a paper without any folds? Now, do y'all know what the dimensions of a piece of paper are? No? Well, so, Mrs. Marrero, do you know what the dimensions of a piece of paper are? 8.5 by 11, that's true. Y'all heard that before? 8.5 by 11? And those are in miles, right? No, they're inches. 8.5 inches, 11 inches. Now it says, what's the area? How do I find the area of a piece of paper or any rectangle? Length times width. Did you say something about the perimeter? No perimeter. Length times width, right? The side blinks. So area equals length times width, which is 8.5 times 11. What's 8.5 times 11? 8.5 times 11. 93.5. What are the units again? Miles? Degrees? Inches? Kinda. This is an area, which is two-dimensional. So it's inches. Y'all don't remember? Hey, squared. Y'all remember that? If you're talking about area, you should know that, right? And you should know that. And you should know this because I taught it to you. All right. Well, anyways, remember, area is always square units. Cool. Now, if you fold that paper in half, here's my illustration of folding that paper in half. The 8.5 it's still 8.5 wide, but instead of being 11, it's been folded in half. What's half of 11? 5.5 inches. Okay, so to get this number one fold, first of all, 0 folds we said was 93.5. So let's fill that in. Before you fold it, it's 93.5 inches squared. I'm just going to put inches squared on top, so I don't have to write it every time. Okay. After one fold, what I'm multiplying is now 8.5 times 5.5. Well, what is 8.5 times 5.5? Boom. 46.75. Now think, how did I get from 93.5 to 46.75? Do you think there's a relationship? Do you think it's decreasing by a certain amount? Now you would think if you fold it in half that it would just be half. Let's make sure though. What is half of 93.5? By golly, it is half. So guess what the pattern is each time? So you can either say divide by 2, or you can say times 1/2. They're the same thing. Times a half is dividing by 2. Same thing. So what I want you to do is fill out this table, okay? So we need to divide by 2 each time. So if you just hit divide 2, hit enter, and enter, and enter, it'll keep dividing by 2 for you, right? So we got 23.375. I'm going to round 2 decimal places, the hundredth place. So 23.38. Okay, and then I got 11.69. That 7 makes the 8 go up. Okay, 5.84. 2.92. And then 1.46. Okay? So again, when you fold it in half, the area cuts in half. You fold it in half, the area cuts in half again. Do you think this is linear? Okay? Half is not subtracting or adding the same number. Okay? It's actually multiplying by a fraction, 1/2. Okay? So the first question is, what's the difference between the number of folds? Again, the difference between the number of folds each time is what? 1, right? But what's the difference between the areas? Okay? So again, half, half. If we're thinking of multiplying, okay? But number 13 is asking us to find the difference, okay? So, let me write this again. Whoops. You can fill this in with the same numbers. again, difference means we are subtracting on the right-hand side. So what is 93.5 minus 46.75? If you take away half from a whole, you're left with the half still, right? But this is half of this, and this is half of this, right? So 93.5 minus 46.75 is actually 46.75. 46.75 minus 23.38 is 23.38, okay? When we round. So again, all these differences are the next half, essentially. All right? Again, if you subtract the next one, that's what you get. And since it's going down, these are all negative. Okay, I'll give you a second to get that down. And then you can flip it over. The last page. Okay. Moving on. So, last page. Are the finite differences between the area of the regions and the number of folds constant? So again, were these differences constant? They're not all the same. So no. The differences differ. What patterns do you observe? So what was happening each time again? Dividing by 2 or multiplying by a half. And we're going to pick the multiplying by a half. Because you have a ratio, you're always multiplying by the ratio. So is it linear? We're not adding or subtracting, so no. Not adding or subtracting. Okay, what is the ratio? So again, what are we multiplying by? 1/2. So remember, this word ratio is when you're multiplying. What would be the area of the region present after the 7th fold? Now, again, this was our last one. We hit enter again. This was our 6th fold. Here's our 7th fold, 0.73. So you can keep the pattern going. Inches squared, right? You can keep the pattern going. Or you could find the equation and look at the table, right? So again, is this what type of function is this? If it's not linear, we call it what? Exponential. It's multiplying by a ratio. All day, right? And then we need an equation. So once again, we're going to put in three pairs into the list and spreadsheet so we can get our equation. So let's do that. First get up to it. Oh my gosh. All right, there we go. So we go to on, list and spreadsheet, X and Y at the top. And then we had 93.5, 23.375 originally. And then no. Sorry. This one was 46.75 and then it's 23.375. Okay. So we hit menu 4-1 what? A for exponential. X is x, y is y. And there you go. Remember how you write it. A times b to the x. So 93.5 times 0.5 to the power of x. Okay? Let's write that down over on number 20. Okay? So again, y equals 93.5 times 0.5 to the power of x. And you could plug that in to graph, hit Control T, get a table, and find any number of terms from that. Okay? So, you can hold on to this, and we're going to use it on tomorrow's assignment for 1.4. If you still haven't finished 1.3, that's due today, so you want to get that done, or anything else, like Pascal's triangle or linear versus exponential. Okay?